All right, I think that we're recording now. Okay, everyone, so welcome to another installment of the philosophy seminar here at UQ. And today it's my great pleasure to have Patrick Girard from the University of Auckland, who is going to be giving a rather non-standard talk, both in format, in presentation, but also in terms of the content. So that should be very exciting. And let's hope that it goes well. Patrick, please take it away.
Thank you everyone for being here. If you want to open your chat window, I'll be putting quotes and references in there. I'll be opening up the whiteboard at some point if I need to write. And yeah, hopefully it all goes well. This is joint work with Koji Tanaka, who's with us here. And Koji, if you're happy with it, and if I say false things or if questions are too difficult for me, I might deflect them to you. And feel free to just stop me if you want to. I mean, Koji can stop me, and Gia, because you're the leader. Otherwise, I'll take friendly questions, but I'll try and keep it short. And it's not a super deep point I want to make. I'll try to contextualize it in a way that can give us a great platform for discussion, and then we can take it from there and see how it's going. This is a bit of variation on the same theme that since I've been doing work in paraconsistent logic for since 2014 or 15 or so, mostly joint work with Zach Weber and then with Guillermo when he joined us. So we created a non-contractive dialectic band, and we wrote a few papers together. And then Koji, in the meantime, has written stuff about impossible worlds. And yeah, we like to chat together, Koji and I, and we talk a lot. And then we've been talking about joint work together. So I've been I had published about bad worlds, and Koji had published about impossible worlds, and this is sort of getting the ideas together and trying to make better sense of a fairly, for me, like, that's my main complaint. It's a bit of a complaint that I keep making, but basically the main point of the talk is that classical meta theory for dialectic logic is bad, where bad is a technical word that will try and make more precise. In particular, that's one of Koji's contribution, is to help make the complaint a bit more precise. And it's bad because the world described by the classical meta theory for a dialectic logic is a bad world. And that means that its logic, the logic of the world, is ruled out by the meta logic that theorizes it. So I'm starting non-apologetic, that's the word I'm trying to say, about being a dialectist anymore. But there's an old complaint that, let me just fetch it here, that comes from Burgess in 2005. I'm going to put this in the chat now. That how far can a logician who professes to hold that paraconsistency or dialetheism or at the time relevant logic or some kind of non-classical logic is the correct criterion of a valid argument, but who freely accepts and offers standard mathematical proofs, in particular for theorems about paraconsistent logic itself, be regarded as sincere or serious in objecting to classical logic. The point being that if you start from the view that logic is normative and that the world is as it is described by a dialectic logic because it has inconsistencies, then and if logic is meant to be normative and there's only one logic to rule it out, then it should be the same logic through and through. And using classical logic in the meta theory sounds insincere. And that's a fair enough complaint that by now, especially with so with the non-contractive band, here I am trying to, okay, no, I don't want to, let me. Yeah, I'll be with you in a second. So here are 3 papers that I've written with Zach and Gia. So the first one, what is an inconsistent truth table? So that was our first joint attempt at using a non-contractive naive set theory in the meta theory to revisit what a truth table is. And a truth table is just a truth table. It's just that we managed to describe it in a non-classical meta theory. Subsequently, I did some joint work with Zach in modal logic in which we looked at definability results, again, using non-contractive logic. So we use non-contractive reasoning in the meta theory, and then we try to see definability results in modal logic. And more recently with Guillermo and Zach, especially because of Guillermo's flair to go back and find old texts and old proofs, we figured out ways to prove in this weird non-contractive dialethic meta theory, we find ways to prove standard theorems, in particular the completeness theorem, the Lowenheim-Skolem theorem, and the compactness theorem for a predicate language. So to a certain extent, this is meeting Burgess' challenge. So we try to be sincere and serious and do it, and to a certain extent, we managed to do it. I wouldn't call it just yet a full recovery of the classical results because we have side conditions. We need to make some assumptions on the way, but in particular that the version of the theorem we prove is the version that was proved in the old proofs at the time, namely the material version. So instead, when the conditional in the statement of the theorems is stated as an if-then, we explicitly state it as a material, not A or B, and we prove it as such. And so the proof is mostly replicated, aside from technicalities and combinatorics that we are forced into because we have fewer tools. But at the end of the day, we prove the material version of the theorems. And then we can complain that it's the classical logician who then makes the further step of then rephrasing the theorem as if then, which we reject. At least we mostly agree on the material part, and we disagree that they should call that conditional statements of those theorems. And this is where we're at. And then Zach on his own has probably what I would think is the best response at the moment. Not the best response, but the best way to meet Burgess' challenge in his book from 2021, in which he's revisiting, basically opening textbooks in mathematics and proving the main results from the first chapters. So in arithmetic and in topology and in geometry and a few places. So it can be done. It's difficult. It's not always a lot of fun because going non-classical in the meta theory makes it very difficult because you can't use all the classical results of mathematics. We're not the first ones to do it. There's a tradition of doing it, for instance, in intuitionistic logic. This paper here by McCarthy and Tennant, and they talk about Skolem's paradox and constructivism. And the paper explores whether or not constructive logic or intuitionistic logic is subjected to Skolem's paradox. And their answer is that it isn't if you are constructive in the meta theory. And there's a disagreement as whether or not the logic is, is subjected to Skolem's paradox depends on the meta logic that you're using. And basically, when the classical logician in a classical meta theory says of intuitionistic logic that it fails, while that also has the Skolem's paradox, that's a classical imposition that can't be proved in the intuitionistic logic. So there is disagreement to be had as to what holds, even if you're in the project of doing recovery. Sometimes you can't recover and you're happy about it, say in the case of Skolem's paradox. Sometimes you can recover, but only with side conditions and indeed being sincere that it's a material proof, not a conditional proof. And then, I'm inviting you all, if you so feel inclined, to do that kind of hard work to pursue how far we can get into non-classical meta-theorizing of worlds. In the meantime, though, I want to these are first indications that going classical can actually, to a certain extent, lead us astray. But here is more of a point that actually, I guess there's been a tradition that in the meantime, we want to be classical in the meta theory because that's where we can understand, we can get better understanding of what the logic looks like. Because in the classical meta theory, we're free to apply mathematics and use all the power of mathematics and get all these nice results. And we can better understand the non-classical logics. And I want to say that this can also lead to bad results. And now I'm going to get into that point. And I'm going to talk in particular as to how I think that the classical representation of the actual as being a dialethic world is bad. And that's the point. Okay, so we'll talk first about, say, possible worlds. What's a possible world? For here, I'm taking a fairly liberal interpretation. So you can think of how David Lewis talked about it in counterfactuals as ways things could have been. That makes it a possible world. Or another Jago here. Let me fetch that reference for you. Jago in 2014 talks about representations of ways the world could be. So that's fine, in that's good enough, but in particular for us, we want here to, I'm going to open a whiteboard, and we're going to say that a possible world is a representation of a world that consists of a set of facts. So a world will have facts. Oops, I need to take my pencil here. Here we go. So facts that are basically atomic facts that keeps on going. And then a set of logical laws. And logical laws, you can think of them as being expressed as entailments, where these are premises. And then you may or may not have multiple consequences, et cetera, et cetera. Okay, so a world then has a non-logical facts and logical laws expressed as entailments. And then if you want to talk about, say, what a paraconsistent world is, a paraconsistent world would then be a world in which you do not have that this is valid. So you do not have this, the world does not have it as a law that everything follows from a contradiction. And that's possible world. Not too complex here, I hope. And maybe I'll say it now. A dialethic world would be a world in which a proposition is true and untrue at the same time. So that would be a world where you have a proposition that is true and that is not true at the same time, or you can think of it as a world making the proposition true and a world not making the proposition true at the same time. And that's how I want to define a dialethic world for the purpose of this talk, and we'll come back to it later on. All good? Koji, we're good? I haven't said anything too false yet? Good. Just a little false, probably. All right, so impossible worlds. Impossible worlds will, for us, be, and this is where I'm relying on Koji's published work here, and there's much more exploration happening here of what basically what it is that people mean when they talk about possible worlds. Sometimes they talk about worlds where the laws of logic are violated. Sometimes they talk about worlds where the laws of logic are different. And sometimes they may talk about worlds that are open worlds. There's a few various options for the purpose of this talk. And because Koji is a wise man, we'll go with the interpretation in which we're talking about a world where the laws of logic are violated. I'll reopen a whiteboard here. As an example, we can go back to Kripke in 1965 when he introduced non-normal worlds to study modal logics. And a non-normal worlds back then was, and still is, I suppose, a world in which necessitation fails. Necessitation is the rule. Oh, I need to take my pen back. The rule that allows you to go from if A is a theorem, then so is box A. And in particular, non-normal worlds would be worlds in which you have, for instance, that A or not A is valid, but you don't have that box A or not A is valid. And what makes it an impossible world with respect to the actual world being assumed to be a normal world, is that at the actual world, you do have as a law that a box A or not A is a logical law. Okay, so I'll say that again. What I'm saying is that in the normal worlds, we always have that, the necessitation of excluded middle comes out as a theorem. When you go to an impossible world, you have instances in which you don't have that box P or not P for particular ones. Actually, all of them, but for some of them. And that's what makes them impossible, because in the real world where you have a law of logic, you have a theorem that then finds a counterexample in the non-normal worlds. And it's so then this idea of an impossible world is relative. It's relative to another world. So the first world has a law. The second world violates it by having a proper counterexample. You happy with that, Koji? All right. Anyone too? Oh, everyone? Is anyone happy? Yeah. All right. Next point, and this is not really the topic of my talk, but basically that the actual world is dialethic. And why is the actual world dialethic? It's because of something like lambda, that is the liar sentence. And it's a fairly standard kind of argument. If, what do we have? We have that if lambda is true, then we can, well, it's easy to show that lambda is true if and only if lambda is, I'll write it as untrue, right? Because assume that lambda is true, then what it says is true, namely that it's untrue. So it's untrue, yeah, so it is untrue. And if it is untrue, then it's not true that it is untrue, and therefore it is true. You then get that lambda is true if and only if it is untrue. But we have that lambda is true, or lambda is untrue. And then if you, so then you can use disjunctive disjunction elimination. If lambda is true, then you get that it's untrue. So it is true and untrue. That's the first element of the proof. The second one is that if lambda is untrue, then you get that it is true. And again, you get that it is true and untrue. And we have now proved that lambda is true. Lambda is true and lambda is untrue. And that happens at the actual world. And that's why the world is dialethic. Big surprise. I mean, I know it, does it still offend people to hear that? I don't know. I got used to it. I no longer get a rash when I give this argument. So here we go. This is the kind of world we live in 2000, in post-COVID world. Okay, so that's okay. We're good with that. I'm sure everyone's good with that. Next step is to then show that the world, the actual world, is not only dialethic, but it is impossible. Here, for instance, we're not the first one to say that. There is a paper, for instance, by Martin. I'll put that in the chat, in which he argues that what you're getting in LP is the previous argument I gave you. This argument is actually a proof that lambda is true and lambda is untrue. And therefore, that makes it true in every possible world. And what you're getting is, no, actually, that's not what I meant to say. Sorry, I'm a bit confused. Scratch that. What Martin says is that we can still prove in something like LP, and that again is well known. You can still prove that the law of contradiction is false. It's just that you always have counterexamples like lambda, because lambda happens to be true everywhere. It still is the case that you can prove that you don't have contradiction. And these kind of proofs are actually necessary. So you can prove that it is necessary that non-contradiction is false. And then you can get, it's not possible just by using standard modal logic, which here is a bit of a detour in metatheory, that you can swap the quantifiers and push the negation outside. That's something that comes out of classical metatheory, but that's not too much my point. My point is just that what you can prove in a classical metatheory is that it's not possible that a contradiction is true, yet the real world does make in LP lambda and not lambda true. And therefore, the way he phrases it is as follows, and I'll paste that in the chat now. Given that an impossible world is a world W where propositions that cannot possibly true are true, any world W at which a contradiction is true is going to be an impossible world, according to the modal semantics given above. The point is that it's not possibly true that a contradiction is true, yet I wrote a phi here that should be a lambda, so I'll erase that. That should be a lambda. Yet lambda is true there. So that was the argument he gave as to why the actual world is impossible. For us, we can go even a little quicker than that. From our definition, it's the same idea, but basically that, again, in LP, we have that this is a law that we have for the real world. So the real world is such that, I did it again, is such that the law of non-contradiction is a law, yet, so that's one of the, I'm abusing notation here. I'm just saying that the law of non-contradiction is a world that holds in the real world, yet the real world makes lambda true, and it makes lambda not true. Not true. So the real world has a proper counterexample to one of its laws, and that makes it impossible by our definition. And maybe you expect me to say, oh, that's bad. The real world can't be an impossible world, so we need to fix it. No, I'm happy with it. That's just a feature. Once you've written a bunch of paper writing these kind of proofs in a dialethic meta theory, you just get used to it. The things you can prove oftentimes find instances that violate the rules. You oftentimes find counterexamples. I call it the but clause. The but clause is that whenever you prove a theorem, you say such and such is valid, but there is a counter instance, such as, oftentimes it's the paradoxical sentences that provide counterexamples. You kind of just get used to it. And that's what it is. Yes, of course, the real world is possible because it's one way the world could be, since it is as it is, but it's also impossible because it has an instance of a fact that violates one of its logical laws. So the world is impossible. You happy with that, Koji? Sweet. Every time I give a talk about this stuff, I feel like I'm getting madder and madder, but so it is. It's all right. Now, Bad Worlds in particular was a project that I had with Zach Weber. Here's the link. And in particular, we had this quote where we said that a bad world is a blanket term for ways the world could not have been, worlds in which the laws of logic are different, arbitrary, go haywire, or fail. Bad worlds are those singled out as a class of deformed netherworlds to be kept separated from the proper world. We were sort of intentionally somewhat rhetorical in writing this paper, and it was that same kind of complaint I'm making today, but we were more vague as to what we meant by what bad worlds were, but basically we meant all the classical use of non-normal worlds or Ratley star worlds, or even the use of ternary relations for the semantics of relevant logic. We're just complaining against it, and we're saying that those are classical artifacts that are classical monsters that classical logicians must use to make sense of non-classical objects, because the consistency that they impose in their meta-theory doesn't allow them to truly entertain the kind of madness that you find in relevant logic and paraconsistent logic when you meet contradictions. Because if the classical meta-theory was to truly entertain it, then it would trivialize. And to avoid this trivializing, it then needs to mimic these worlds, to mimic it, and to produce these sorts of monstrous and mathematical objects that mimic what's really going on as best as it can. But that doesn't really get at the heart of it, because we want to know how it is, not how it is represented in a different kind of framework. So that's the kind of complaint we had at the time. But in particular, a bad world, then that's thanks to Koji, because Koji kept asking me, what do you mean? What do you mean? What do you mean? And now we have something that is a bit more precise. At least in this paper, we're now trying to offer a more precise definition of what a bad world is. And a bad world would then be when the logic of the meta-theory fails to match the logic that is theorized. So take, for instance, Routley that became Sylvan and Plumwood back in 1972, wrote a paper together on the semantics of first-degree entailment. And in particular, they give us that quote. So that's one of the first time that the star worlds happen. So when H is like a world W, so I'll write W because I'm more used to write W. So we have W and we have W star. So when they differ, tautologies will often fail or contradiction hold in one or other of H and H star. So to illustrate, consider A and not A in case H is different from H star, then A and not A is in H if A is in H and A is not in H star. And then it's a consistent assignment. So that's what bugs me is they insist that it's fine, we're talking in classicalese, we're giving you a consistent assignment. And that's what makes it bad, basically. So what they're saying is you would have something like P being true here and P failing to be true at W star. And because P fails to be true at a different world, then you can get that not P is the case. And then you can mimic that P and not P is true at world W. So the classical logic can witness that a contradiction can sort of be said to be true at a world, but not because the world itself is such that P is true and untrue at the same time. It's because P is true at W and P is untrue somewhere else. And for all I know, and I may be wrong here, but I'll make a swooping claim here that all worlds in relevant logic are always consistent, even though they can mimic contradiction in the semantics in that kind of way. And that's bad. Basically, contradictions that are represented are resolved in the meta logic, and that's what's bad. Koji, you happy with that too? Wow, I'm doing good. I've got Koji thumbs up. Sweet. And then we're basically there at the end of the talk now, is that I was talking about, where did I talk about that? Yes. So here it is, that because the world, the real world is a dialethic world, it makes lambda being true and lambda being untrue. And when we represent it in a classical meta theory, the classical meta theory that you're probably aware of, that uses designated values, so it's usually a 3-valued logic that has designated values, it still is the case that the classical logic resolves the mimicked contradiction that occurs in the world. But the world is dialethic. It does make lambda true and lambda untrue, yet in a classical meta theory, we can't fully represent that. So I'll just read what I have here. A classical meta theory resolves the contradiction of the logic that holds in the world. There's no facts that are both designated and undesignated, but lambda is designated in a consistent world. So the meta logic that theorizes the logic rules out the logic that holds in the world, and that's bad. So not only so we're okay with the real world being impossible for the reasons that we gave you, because it has a specific counterexample to a logical law that holds at the world. But what's worse when you go classical in the meta theory is that you produce a bad world, and that's bad. So we want it to only be impossible, not to be bad. The end. Oh, I guess I can just you know, I'll just to circle back to Burgess' complaint against at the very start. I'll just repaste it here at the bottom. You know, it's about sincerity and seriousness, and there's a sense in which you know, I didn't agree with Burgess saying that non-classical logic is bad because everything is done in classical logic. I think non-classical logic is good, but to stay and remain good and sincere and serious, it has to be done with one logic to rule it all, or at least a non-classical logic as well. So coming back to reinforce Burgess' point, but not necessarily the rejection of non-classical logic. So I want to endorse non-classical logic, but invite you to do it with in a good way. And okay, now I'll shut up. Koji, do you have anything to say? Are you happy with whatever I said? Double thumbs up from Koji. All right, we'll go with that. That's me. Thank you.